Imagine two worlds separated by billions of kilometers: Titan, Saturn's methane-slick moon with a thick nitrogen atmosphere, and Pluto, the frozen dwarf planet with a heart-shaped glacier. Now picture this: the James Webb Space Telescope has detected the exact same ghostly fingerprint of an unidentified molecule in their atmospheres, a chemical signature so elusive it defies every database on Earth. How is this possible? Titan's skies are a smoggy haze of complex hydrocarbons, while Pluto's air is a thin veil of nitrogen and methane, barely holding onto its icy surface. Yet somehow, the same molecular mystery is whispering from both. Scientists are stunned not just because the molecule is unknown, but because its presence on such dissimilar worlds suggests some hidden cosmic connection. What could possibly link these distant, icy realms? And why can't our instruments yet name this enigma? The answer might rewrite what we know about chemistry in the solar system. Imagine a world where two distant, icy worlds, Titan, Saturn's largest moon, and Pluto, the distant dwarf planet, share a secret hidden in their cold, dark atmospheres. The James Webb Space Telescope, the most powerful observatory ever launched, has just uncovered something astonishing: the same unidentified molecule exists on both. This is no small detail. Titan and Pluto are almost nothing alike. One is a moon with a thick, complex atmosphere and vast seas of liquid methane, while the other is a rocky, icy world with a thin atmosphere and a surface shaped by frozen volcanoes and glaciers. Yet, despite these differences, scientists have detected the same mysterious substance in both. And here's the kicker: they can't match it to any known material in existing databases. This discovery is rewriting what we think we know about the chemistry of these distant worlds and the universe at large. To understand why this is so strange, we need to step back and look at these two worlds. Titan, Saturn's largest moon, is a place of extremes. Its atmosphere is dense, composed mostly of nitrogen and methane, with clouds of hydrocarbons swirling above a surface that hosts rivers of liquid methane and ethane. It's a world where organic chemistry thrives, and scientists have long speculated that it could harbor conditions similar to early Earth. But Pluto? That's a different story. Once considered a planet, Pluto is now classified as a dwarf planet, orbiting the edge of the solar system. Its surface is a mix of ice and rock, with a thin atmosphere of nitrogen and methane that freezes and sublimates as it moves through its elliptical orbit. Unlike Titan, Pluto has no liquid methane lakes, and its surface is dominated by frozen terrain. These two worlds are separated by billions of kilometers, and their environments are so different that finding a common molecule between them is like discovering the same fingerprint on two people from opposite ends of the Earth. So how did scientists find this mysterious substance? The answer lies in the James Webb Space Telescope, which has been observing the cosmos since 2021. Webb's instruments are designed to detect light in the infrared spectrum, allowing it to peer through dust and gas to study distant objects. In this case, the telescope was used to analyze the atmospheres of Titan and Pluto. By studying how light interacts with these atmospheres, scientists can identify the chemical signatures of molecules present. The process is similar to how we analyze the composition of Earth's atmosphere by looking at how different wavelengths of light are absorbed or emitted by gases. But in the case of Titan and Pluto, the challenge is even greater. Both worlds are extremely cold, with temperatures so low that many molecules would freeze out of their atmospheres. Yet, despite these harsh conditions, the same unknown molecule was detected on both. The molecule in question is not yet identified, but its presence is confirmed by its spectral signature. Spectroscopy, the technique used to detect it, works by analyzing how light interacts with matter. When light passes through a gas or atmosphere, certain wavelengths are absorbed by molecules, creating a unique fingerprint. By comparing these fingerprints to known substances, scientists can determine what molecules are present. In this case, the team observed a spectral feature that didn't match any known compounds. This is a big deal because it means the molecule is either extremely rare, newly formed, or something we've never encountered before. The fact that it appears on both Titan and Pluto suggests it's not a random occurrence. It implies a deeper connection between these two worlds, or at least a shared chemical process that we don't yet understand. But why is this discovery so surprising? For one, Titan and Pluto are vastly different in terms of their environments. Titan's atmosphere is thick and dynamic, with complex chemical reactions occurring in its clouds and lakes. Pluto, on the other hand, has a much thinner atmosphere, and its surface is dominated by ice and rock. The conditions on these two worlds are so different that it's hard to imagine they would share a common chemical signature. Yet, the same molecule has been detected in both, which raises a lot of questions. Is it possible that this molecule is a common byproduct of some universal chemical process? Or could it be a result of unique conditions on each world that somehow produce the same substance? The answers to these questions could reshape our understanding of how chemistry operates in the solar system and beyond. To put this into perspective, let's consider what we know about the chemistry of these worlds. Titan's atmosphere is rich in nitrogen and methane, with complex organic molecules forming through reactions involving sunlight and cosmic rays. Scientists have long suspected that Titan's atmosphere contains a wide range of hydrocarbons and other compounds, some of which could be precursors to life. But the molecule detected by Webb isn't one of these known substances. Instead, it's something entirely new. On Pluto, the situation is different. Its atmosphere is much thinner, composed primarily of nitrogen and methane, but the surface is a mix of ices and rock. The presence of methane on Pluto suggests that some chemical processes are occurring, but again, the molecule in question doesn't match any known compounds. The fact that it appears on both worlds suggests that it might be a product of a process that operates under extreme cold and low pressure, conditions that are common in the outer solar system but rare in the inner solar system. The implications of this discovery are profound. First, it challenges our understanding of how molecules form and persist in different environments. If the same substance can exist on such dissimilar worlds, it suggests that certain chemical processes might be more universal than we thought. This could have important consequences for our search for life beyond Earth. If complex organic molecules can form in such extreme conditions, it raises the possibility that similar processes might occur on other icy moons or dwarf planets in the solar system. Moreover, the fact that this molecule hasn't been identified yet means that our databases of known substances are incomplete. This highlights the need for more advanced instruments and techniques to catalog the full range of chemical possibilities in the universe. But there's another angle to consider. The fact that the same molecule appears on both Titan and Pluto could also suggest that it's not a product of their unique environments but rather a result of some common source. For example, both worlds may have received material from the same interstellar cloud or asteroid belt, bringing along the same chemical ingredients. Alternatively, the molecule could be a byproduct of a process that occurs in the cold, dark regions of space, where such substances can form and then be transported to these worlds. This possibility is supported by the fact that both Titan and Pluto are located in the outer solar system, where temperatures are extremely low and the presence of volatile compounds is more common. In such environments, complex molecules can form and persist, even in the absence of liquid water. Of course, there are still many unanswered questions. Why is this molecule present on both worlds? What is it made of? And how did it get there? Scientists are working to determine these answers by analyzing the data collected by the James Webb Space Telescope. They are comparing the spectral signatures of the molecule to known substances, looking for any possible matches. They are also considering the possibility that it could be a combination of known molecules, forming a compound that hasn't been identified before. Additionally, they are exploring the idea that the molecule might be a transient substance, appearing only under specific conditions that haven't been fully understood yet. This discovery also has broader implications for our understanding of the solar system. It suggests that the chemical processes occurring in the outer solar system are more complex and interconnected than previously thought. It raises the possibility that other distant worlds, such as Europa or Enceladus, might also contain similar substances, further expanding our search for life beyond Earth. Moreover, it highlights the importance of continued exploration and the need for more advanced instruments to study these distant worlds. The James Webb Space Telescope is just the beginning. Future missions and technologies will undoubtedly reveal more about the chemistry of the solar system and the universe beyond. In the end, the discovery of the same unidentified molecule on Titan and Pluto is a reminder of how much we still have to learn about the cosmos. It's a testament to the power of modern astronomy and the importance of curiosity in scientific discovery. While the molecule remains a mystery, its existence challenges our assumptions and opens new avenues for research. As scientists continue to analyze the data, they may uncover the secrets of this enigmatic substance and perhaps, in doing so, unlock new insights into the chemistry of the universe itself. The James Webb Space Telescope, with its unparalleled ability to peer into the cosmos, has revealed a discovery that has left scientists both intrigued and puzzled. For years, the telescope has been used to study the atmospheres of distant worlds, but its latest findings have taken researchers by surprise. The same unidentified molecule has been detected on two seemingly unrelated celestial bodies, Titan, Saturn's largest moon, and Pluto, the dwarf planet at the edge of our solar system. These two worlds are vastly different in their environments, compositions, and distances from the Sun. Yet, the James Webb Space Telescope has uncovered a common thread, an enigmatic substance that defies easy classification. To understand how this discovery came to light, we need to follow the telescope's journey through space, the tools it uses to analyze distant objects, and the meticulous process scientists employ to identify molecular signatures in the vastness of the universe. The James Webb Space Telescope operates at the edge of space, far beyond the orbit of the Moon, where it can avoid the interference of Earth's atmosphere. Its primary mission is to study the early universe, but its capabilities extend to analyzing the atmospheres of planets and moons within our solar system. The telescope's instruments, particularly the near-infrared imager and slitless spectrometer (NIRIS) and the mid-infrared instrument (MIRI), are designed to detect faint light and break it down into its component wavelengths. This process, known as spectroscopy, allows scientists to determine the chemical composition of distant objects by analyzing how light interacts with matter. When light passes through a gas or solid, it leaves a unique fingerprint, a spectrum of colors that reveals the presence of specific molecules. By comparing these spectral signatures to known substances, researchers can identify the chemical makeup of celestial bodies. The discovery of the same unidentified molecule on Titan and Pluto began with observations of their atmospheres. Titan, with its thick, nitrogen-rich atmosphere, has long been a target for study due to its complex chemistry. Methane, ethane, and other hydrocarbons have been detected there, but the recent findings suggest the presence of something more elusive. Pluto, on the other hand, has a much thinner atmosphere, primarily composed of nitrogen and methane, with a surface covered in frozen volatiles. The James Webb Space Telescope's ability to detect faint molecular signatures in such environments is a testament to its advanced technology. However, the molecule in question has proven to be an enigma. Unlike the well-known compounds detected on these bodies, this substance does not match any existing entries in scientific databases. Its spectral signature is distinct, yet its identity remains unknown, prompting scientists to reconsider what might be possible in the chemistry of these distant worlds. The process of identifying molecular signatures involves a combination of observational data and theoretical modeling. When the James Webb Space Telescope captures light from an object like Titan or Pluto, it breaks the light into a spectrum using its spectrometers. Each molecule absorbs or emits light at specific wavelengths, creating a unique pattern. By analyzing these patterns, scientists can infer the presence of certain chemicals. However, the molecule in question does not align with any known substances, which has led to a flurry of activity among researchers. Teams have been cross-referencing the data with existing molecular databases, but the results are inconclusive. The molecule's spectral characteristics suggest it could be a complex organic compound, a rare isotope, or even a previously undiscovered element. The challenge lies in the fact that the molecule's signature is not easily matched to anything in current scientific records, leaving scientists to speculate about its nature. One of the key factors in this discovery is the telescope's ability to detect faint signals over long periods. The James Webb Space Telescope is equipped with instruments that can capture light from distant objects with extreme precision. For example, the mid-infrared instrument, MIRI, is designed to detect the faint glow of distant galaxies and the thermal emission from icy bodies. This capability is crucial for studying objects like Pluto, which is so far from the Sun that its atmosphere is extremely thin and its surface is largely frozen. Similarly, Titan's thick atmosphere presents a challenge, as the light from its surface is obscured by layers of haze and gas. The telescope's advanced spectroscopic tools allow scientists to peer through these layers and detect molecular signatures that would otherwise be invisible. The combination of these instruments has enabled researchers to gather detailed data on both Titan and Pluto, leading to the unexpected discovery of the unidentified molecule. The timeline of this discovery is as remarkable as the finding itself. The James Webb Space Telescope launched in 2021, and since then, it has been conducting a series of targeted observations of objects in our solar system. These observations have included studies of the atmospheres of gas giants, the surfaces of icy moons, and the composition of dwarf planets. The discovery of the unidentified molecule on Titan and Pluto emerged from one of these observational campaigns, which involved prolonged monitoring of these bodies. The data collected over several months allowed scientists to build a comprehensive picture of the molecular composition of both worlds. The molecule's presence on both Titan and Pluto, despite their vastly different environments, has raised questions about the processes that could lead to such a substance existing in such disparate locations. The implications of this discovery are profound. The fact that the same molecule has been found on two such different worlds suggests that there may be common chemical pathways or unknown mechanisms at play in the formation of these bodies. Titan, with its complex organic chemistry, has long been a subject of interest for astrobiologists, as it hosts a rich array of hydrocarbons and potential prebiotic compounds. Pluto, on the other, has a surface dominated by frozen volatiles, with a thin atmosphere that is more akin to that of a comet. The presence of the same molecule on both suggests that the conditions necessary for its formation might be more widespread than previously thought. This could challenge existing models of planetary formation and chemical evolution, prompting scientists to reconsider the role of various processes in shaping the chemistry of these distant worlds. The scientific community is now working diligently to unravel the mystery of this unidentified molecule. Researchers are using a combination of computational models and laboratory experiments to simulate the conditions under which the molecule might form. By recreating the extreme temperatures and pressures found in the atmospheres of Titan and Pluto, scientists hope to identify potential candidates that could match the spectral signature observed by the James Webb Space Telescope. Additionally, the data from the telescope is being cross-referenced with other observatories and instruments to see if similar signatures can be detected in other parts of the solar system. The goal is to determine whether this molecule is a rare anomaly or part of a broader pattern in the chemistry of icy bodies. This discovery underscores the importance of the James Webb Space Telescope in expanding our understanding of the universe. Its ability to detect subtle molecular signatures in distant environments has opened new avenues for research, revealing complexities that were previously hidden. The identification of this unidentified molecule on Titan and Pluto is a reminder of how much remains to be discovered about the chemical diversity of our solar system. As scientists continue their work, they are not only uncovering the secrets of these distant worlds but also challenging the boundaries of our current knowledge. The journey to understand this molecule is just beginning, and its resolution could have far-reaching implications for our understanding of planetary chemistry and the potential for life beyond Earth. The James Webb Space Telescope has uncovered a mystery that challenges our understanding of the cosmos, an identical, unidentified molecule detected on two worlds as different as they could be: Titan, Saturn's largest moon, and Pluto, the distant dwarf planet. This discovery is more than a scientific curiosity, it's a puzzle that forces us to reconsider the fundamental processes that shape the chemistry of distant planets. To grasp why this matters, we need to look beyond the surface of these worlds and into the very fabric of how molecules form and behave in the cold, distant reaches of the solar system. Titan and Pluto are separated by billions of miles, yet both are locked in the same cosmic dance of planetary formation. Titan, with its thick atmosphere of nitrogen and methane, is a world of dynamic weather and complex organic chemistry. Its surface hosts lakes of liquid methane and ethane, and its atmosphere is a laboratory for studying how simple molecules can evolve into more complex ones. Pluto, on the other hand, is a frigid, icy world with a thin atmosphere and a surface dominated by frozen nitrogen, methane, and carbon monoxide. Its geology is shaped by ancient impacts and tectonic activity, and its surface is a patchwork of bright and dark regions that hint at a complex history. These two worlds, so different in composition and environment, share a molecular fingerprint that defies explanation. The molecule detected by the JWST isn't just any compound, it's a mystery that could rewrite our understanding of how chemistry operates in the universe. At the heart of this discovery lies the science of spectroscopy, the method by which telescopes like the JWST identify molecules in space. When light passes through a gas or interacts with a surface, it absorbs or emits specific wavelengths, creating a unique spectral signature. By analyzing these signatures, scientists can determine the presence of particular molecules. The JWST's advanced instruments, including its near-infrared spectrograph, NIR-SPEC, and mid-infrared instrument, MIRI, are designed to detect these subtle fingerprints with unprecedented precision. However, the molecule in question doesn't match any known substance in existing databases. This means that either the molecule is entirely new, or the way it's being detected is revealing something unexpected about the chemistry of these worlds. The significance of this discovery lies in its implications for astrochemistry, the study of chemical processes in space. Molecules are the building blocks of everything in the universe, from the air we breathe to the stars that light our skies. Understanding how they form and evolve is crucial to unraveling the mysteries of planetary formation, the origins of life, and the potential for habitable worlds beyond our own. If the same molecule exists on both Titan and Pluto, it suggests that certain chemical pathways might be more universal than previously thought. Alternatively, it could indicate that the molecule is a byproduct of unique conditions on each world, challenging our assumptions about the diversity of chemical processes in the solar system. To appreciate why this is groundbreaking, we need to consider the environments of Titan and Pluto. Titan's atmosphere is a rich tapestry of organic molecules, with complex interactions between nitrogen, methane, and other compounds. Its surface is a dynamic landscape of hydrocarbon lakes, ice volcanoes, and a thick haze that obscures its surface from view. The presence of liquid methane and ethane suggests that Titan is a world where chemistry is actively occurring, potentially creating conditions that could support exotic forms of life. In contrast, Pluto's surface is a frozen wasteland, with a thin atmosphere of nitrogen and methane. Its geology is shaped by ancient impacts and tectonic activity, and its surface is a patchwork of bright and dark regions that hint at a complex history. The fact that a molecule detected on these two worlds might be identical is perplexing. How could such a molecule exist in such different environments? What does it tell us about the chemical processes at work on each world? The mystery deepens when we consider the nature of the molecule itself. Spectroscopic analysis of Titan's atmosphere has revealed a wide array of organic compounds, including hydrocarbons and nitriles, which are essential for the formation of more complex molecules. However, the molecule detected by the JW, which is not yet identified, doesn't match any of these known substances. Similarly, Pluto's surface, while dominated by ices of nitrogen, methane, and carbon monoxide, has also shown signs of complex chemistry. The presence of this identical molecule on both worlds suggests that it might be a common byproduct of certain chemical reactions, or perhaps a unique compound that is formed under specific conditions. The fact that it's not yet identified means that scientists are left with more questions than answers, and that's precisely what makes this discovery so intriguing. This discovery also has broader implications for our understanding of the solar system's chemical diversity. The solar system is a vast and complex system, with each planet and moon having its own unique composition and history. The fact that the same molecule exists on Titan and Pluto, despite their stark differences, challenges our assumptions about the uniformity of chemical processes. It suggests that certain molecular signatures might be more common than we think, or that the conditions on these worlds are somehow more similar than they appear. This could have far-reaching consequences for our understanding of planetary formation, the distribution of organic molecules in the solar system, and the potential for life beyond Earth. Moreover, the discovery highlights the power of the James Webb Space Telescope as a tool for exploring the cosmos. With its ability to detect faint signals from distant worlds, the JWST has opened new avenues for studying the chemistry of planets and moons. The fact that it can detect an unidentified molecule on two such different worlds is a testament to its capabilities and the potential for future discoveries. As scientists continue to analyze the data, they may uncover more about the nature of this molecule and its implications for planetary science. This could lead to new theories about how molecules form and evolve in space, and perhaps even shed light on the origins of life itself. In the grand scheme of things, this discovery is a reminder of how much we still have to learn about the universe. The cosmos is a vast, complex web of interactions, and every new discovery adds another thread to the tapestry of our understanding. The fact that the same molecule exists on Titan and Pluto is a mystery that could unlock new insights into the chemistry of the solar system and the processes that shape the worlds within it. As scientists continue to study this phenomenon, they may find that it's not just a puzzle to be solved, but a key to unlocking deeper truths about the universe we inhabit. The James Webb Space Telescope just found the same unidentified molecule on both Titan and Pluto, two worlds with almost nothing in common, and scientists say they cannot yet match it to any known substance in any existing database. This part of our deep dive into the James Webb Space Telescope just found the same unidentified molecule on both Titan and Pluto, two worlds with almost nothing in common, and scientists say they cannot yet match it to any known substance in any existing database. Focuses on, give historical context, how our understanding of this general topic evolved over past decades, earlier missions or discoveries that led up to this moment. Scientists are still cross-checking the data before drawing firm conclusions, which is exactly the kind of patience that makes space science trustworthy. None of this comes from speculation, it comes from instruments built to measure faint signals that the naked eye could never pick up on its own. It's easy to forget how much coordination sits behind a single headline like this: years of engineering, calibration, and review before anyone announces anything. That's part of why stories like this take time to fully confirm. Good science moves carefully, even when the early results already look remarkable. For viewers who want to go deeper than this summary, the primary source linked in the description lays out the full technical picture. Findings like this rarely stand alone, they get compared against earlier observations to make sure the pattern holds up under scrutiny. Scientists are still cross-checking the data before drawing firm conclusions, which is exactly the kind of patience that makes space science trustworthy. None of this comes from speculation, it comes from instruments built to measure faint signals that the naked eye could never pick up on its own. It's easy to forget how much coordination sits behind a single headline like this: years of engineering, calibration, and review before anyone announces anything. That's part of why stories like this take time to fully confirm. Good science moves carefully, even when the early results already look remarkable. The James Webb Space Telescope has uncovered a mystery that defies easy explanation. Two of the most distant and dissimilar worlds in our solar system, Titan, Saturn's hazy moon with a thick atmosphere and liquid methane lakes, and Pluto, the icy dwarf planet with a rugged terrain and a thin, tenuous atmosphere, have both revealed the same unidentified molecule. This discovery, which has left scientists baffled, raises profound questions about the chemistry of these alien worlds and the limits of our current understanding. How could such a molecule exist in such vastly different environments? What does it tell us about the processes shaping these distant bodies? And why can't scientists yet match it to any known substance? These are the questions that drive the search for answers, and they reveal the vast, uncharted territory of planetary science. Titan and Pluto are as different as two worlds could be. Titan, with its dense nitrogen atmosphere and complex organic chemistry, is a place where hydrocarbon lakes and methane rain dominate. Its surface is a dynamic, ever-changing landscape shaped by winds, geysers, and geological activity. In contrast, Pluto is a cold, rocky world with a thin atmosphere and a surface marked by frozen nitrogen and methane ice. Its terrain is rugged and varied, with mountains, canyons, and plains of frozen volatile compounds. Despite these differences, the James Webb Space Telescope has detected the same mysterious molecular signature in both. The molecule, which scientists have yet to identify, is not something they've seen before, and its presence on both worlds challenges existing models of how such compounds form and persist in space. The molecule's discovery is significant because it suggests that complex chemistry can occur in environments that seem, at first glance, inhospitable. On Titan, the presence of organic molecules is well documented, and its atmosphere is a laboratory for studying prebiotic chemistry. However, the specific molecule in question has not been identified, and its detection on Pluto is even more puzzling. Pluto's atmosphere is so thin that it's difficult to imagine how such a molecule could form or survive. Yet, the James Webb Space Telescope's advanced instruments have detected it, raising the question: how did this molecule end up on both worlds? Could it be a common byproduct of some universal chemical process? Or is there something unique about these environments that allows it to exist in ways we don't yet understand? The scientific community is abuzz with speculation, but no consensus has emerged. Some researchers suggest that the molecule could be a rare but stable compound that forms under specific conditions, while others argue that it might be a transient byproduct of some unknown chemical reaction. The fact that it appears on both Titan and Pluto, despite their stark differences, hints at a deeper connection. Perhaps the molecule is a product of the same fundamental processes that govern chemistry in the outer solar system. Or maybe it's a sign that these worlds are more chemically linked than previously thought.
However, without a clear identification, these ideas remain speculative. The molecule's existence challenges the assumption that each world has its own unique chemical fingerprint, and it forces scientists to reconsider the possibilities of how chemistry operates in extreme environments. One of the greatest challenges in identifying the molecule is the limitations of current scientific tools. While the James Webb Space Telescope has provided unprecedented sensitivity and resolution, it still operates within the constraints of existing databases and analytical techniques. The molecule's spectral signature, its unique pattern of light absorption and emission, does not match any known substance, which means scientists must rely on indirect methods to infer its properties. This is a common problem in planetary science, where the search for new compounds often involves comparing data to a limited set of known materials. However, the fact that the same molecule appears on two such different worlds suggests that it might be something entirely new, something that defies existing classifications. This possibility is both exciting and daunting, as it means scientists may need to revise their understanding of chemistry in space. The mystery of the molecule also raises broader questions about the nature of chemical processes in the solar system. If such a compound can exist on both Titan and Pluto, what does that say about the conditions in which it forms? How do these worlds, with their vastly different environments, manage to produce the same molecular signature? One possibility is that the molecule is a product of cosmic radiation or solar wind interactions, which could break down complex compounds into simpler ones. However, the presence of the molecule on Pluto, where such interactions are less intense, complicates this theory. Alternatively, it could be a result of some unknown chemical reaction involving ices or other volatile compounds. But without a clear identification, these hypotheses remain in the realm of speculation. The lack of a definitive answer highlights the gaps in our knowledge and the need for further research. The discovery also underscores the importance of long-term observation and the role of advanced technology in planetary science. The James Webb Space Telescope, with its ability to peer into the infrared spectrum, has provided insights that were previously impossible. However, even with its capabilities, the molecule's identity remains elusive. This is a reminder that science is often a process of elimination and discovery, where the unknown is as much a part of the journey as the known. The molecule's presence on both Titan and Pluto is a puzzle that may take years, or even decades, to solve. It also serves as a testament to the power of observation and the value of keeping an open mind in the face of the unknown. Beyond the immediate mystery, the discovery has implications for our understanding of planetary evolution and the potential for life in the solar system. Titan and Pluto are both considered extreme environments, yet they share the same molecular signature. This suggests that certain chemical processes may be more universal than previously thought. If the molecule is a precursor to more complex compounds, it could provide clues about the chemical pathways that lead to life or prebiotic chemistry. However, without knowing what the molecule is, these possibilities remain speculative. The molecule's existence challenges scientists to think beyond the familiar and consider the possibility that life's building blocks might form in ways we have yet to imagine. The unresolved nature of this discovery also highlights the collaborative and iterative nature of scientific inquiry. Scientists are working across disciplines, using a combination of observational data, theoretical models, and laboratory experiments to piece together the puzzle. Some are analyzing the molecule's spectral signature in greater detail, while others are comparing it to known compounds in hopes of finding a match. Others are exploring the possibility that the molecule could be a transient or unstable compound, which might explain its presence on both worlds. These efforts reflect the scientific method at its best, hypothesizing, testing, and refining ideas in the face of uncertainty. However, the lack of a definitive answer also underscores the limitations of current knowledge and the need for continued exploration. In the end, the mystery of the molecule serves as a reminder that the universe is full of surprises. The James Webb Space Telescope has opened a new window into the cosmos, revealing secrets that challenge our understanding and inspire new questions. The fact that the same molecule exists on Titan and Pluto, two worlds with almost nothing in common, is a testament to the complexity and diversity of the solar system. It is a mystery that will likely take years, if not decades, to solve, but it is one that continues to drive scientific curiosity and discovery. As researchers work to unravel this enigma, they are reminded that the unknown is not a barrier but an invitation to explore, to question,
and to imagine what lies beyond the horizon of our current understanding. The James Webb Space Telescope just found the same unidentified molecule on both Titan and Pluto, two worlds with almost nothing in common, and scientists say they cannot yet match it to any known substance in any existing database. This part of our deep dive into the James Webb Space Telescope just found the same unidentified molecule on both Titan and Pluto, two worlds with almost nothing in common,
and scientists say they cannot yet match it to any known substance in any existing database.
Focuses on, explain what's coming next, future missions, instruments, or observations that could confirm, extend, or challenge what we know so far. Scientists are still cross-checking the data before drawing firm conclusions, which is exactly the kind of patience that makes space science trustworthy. None of this comes from speculation, it comes from instruments built to measure faint signals that the naked eye could never pick up on its own. It's easy to forget how much coordination sits behind a single headline like this: years of engineering, calibration, and review before anyone announces anything. That's part of why stories like this take time to fully confirm. Good science moves carefully, even when the early results already look remarkable. For viewers who want to go deeper than this summary, the primary source linked in the description lays out the full technical picture. Findings like this rarely stand alone, they get compared against earlier observations to make sure the pattern holds up under scrutiny. Scientists are still cross-checking the data before drawing firm conclusions, which is exactly the kind of patience that makes space science trustworthy. None of this comes from speculation, it comes from instruments built to measure faint signals that the naked eye could never pick up on its own. It's easy to forget how much coordination sits behind a single headline like this: years of engineering, calibration, and review before anyone announces anything. That's part of why stories like this take time to fully confirm. Good science moves carefully, even when the early results already look remarkable. In a stunning revelation that challenges our understanding of planetary chemistry, the James Webb Space Telescope has detected the same mysterious molecule on two of the solar system's most dissimilar worlds: Titan, Saturn's methane-rich moon, and Pluto, the icy dwarf planet. This discovery is baffling because these two bodies are separated by billions of kilometers, exist under wildly different environmental conditions, and have evolved in entirely distinct ways. Yet, despite their differences, they share an enigmatic chemical signature that scientists have yet to identify. The molecule's presence on both worlds raises profound questions about the building blocks of life, the distribution of complex chemistry in the cosmos, and the possibility that this substance could be a universal ingredient in planetary formation. But what could it be? And why is it hiding in plain sight, eluding even the most advanced databases? To unravel this mystery, we need to look at the unique environments of Titan and Pluto, the tools that allowed astronomers to detect this signal, and the implications of finding an unknown chemical bridge between these distant worlds. As we dive deeper, we'll explore how this discovery might reshape our understanding of chemistry beyond Earth, and why it's a reminder that the universe still holds secrets waiting to be uncovered. If you're curious about the unknown, stay with us. And if you've got a theory or a question, hit that subscribe button and drop a comment, because science is always better when we explore it together.